Two blocks connected by a light horizontal rope sit at rest on a horizontal frictionless surface. So our surface here is frictionless. Okay, and then block A has mass of 15 kilogram and block B has mass M. So this one is 15 kilogram and we have mass B is unknown. Okay, and then a constant horizontal force F is equal to 60 Newton is applied to block A. So we have F here is equal to 60 Newton. In the first 5 seconds after the force is applied, block A moves 18 meters to the right. So it moves 18 meters to the right. So we will have our X here is equal to 18 meters. And then the time here is 5 seconds. Okay. While the blocks are moving, what is the tension T in the rope that connects between the two blocks? Okay, so we need to find out what is this T, right? And then what else? What is the mass of block B? Okay, so we need to find out this T and the mass of block B here, right? And I think we can use this sentence here. This is kinematics, right? And also this one here, it starts with at rest, so we will have our V0 here is equal to 0 meter over second. Good. And I think we can use the kinematics formula. X is equal to the initial velocity multiplied by t plus 1/2 multiplied by the acceleration multiplied by t squared. And we know everything except for the acceleration, right? So now we plug in the 18 here. So we have 18. And then V0 is 0. T is 5. Good. And then we will have 1/2 A multiplied by 25. Right? Because that will be 5 squared. Or maybe I need to write it like this. 5 squared. Good. Now we will have 18. And that will equal to 5 squared is 25 divided by 2 multiplied by A. Or we will have our A here is equal to 18 times 2 divided by 25. I think we just leave it into calculator here. So what is it? 18 times 2 divided by 25. Okay, and that will be 1.44. 1.44 meter over square second. Good. And that is the acceleration, right? Good. Now, if we see here, we pull this block A and B together, right? Let's see it as one system together. So this block here, we can assume it as one big block, right? So we will have the force here pulling it like this. So we'll have F is equal to 60 Newton. And we have one system combined here. Okay, and the mass of the rope is negligible. So we only have the mass of A plus mass of B, right? However, we can have the Newton's second law here. Sigma F is equal to the mass times acceleration. Okay, and the only force that works on the system is this one. So I will have 60 here. And the mass is mass of A plus mass of B multiplied by the acceleration, which is 1.44. Good. But then block A is 15 kilograms. So I have 60 is equal to 15 plus MB, then multiplied by 1.44. And we can isolate the one that is in the bracket. So I have 15 plus MB, and that will equal to 60 divided by 1.44. Okay, and that will be 41.67. 41.67, and we can isolate that for MB by subtracting 15 to the both sides. So I have 41.67 minus 15, and that is the mass of B, right? And that will be, what is it? 41.67 minus 15. So we have 26.67. And the unit here will be in kilogram. And this is the answer for question B. What is the mass of block B? Okay. But we need to find out the tension T, right? So how to answer that? We need to see the block B only, right? So we will have this one here. And in the block B, we have the force that pulling it is only the tension, right? And we have the mass of block B here, pulled by this T. So we have MB. And here again, we can just use the Newton's second law. Sigma F is equal to the mass times acceleration. The acceleration is the same because they are moving together, right? And the only force that works here is T. Okay, and then the mass only MB, good. And the acceleration here is this one, okay? But I want to put the numerical values later, right? So we'll have our T here. That will be mass of B. Mass of B is this one, 26.67. And then the acceleration is 1.44. Good, and let's plug that into our calculator. 26.67 times 1.44. And I will have 38.40. 38.40, and the unit here will be in Newton. And this is the answer for question A. So here we have the tension of the rope is 38.40 Newton. And then the mass of block B here is 26.67. And that is the answer for question A and question B. Okay, we have answered all the question here. Hopefully, I did not make any mistakes during my calculation. Let me know if I did. And do not forget to like the video, subscribe to the channel, and leave me a comment if you spot any mistakes. Thank you for watching and see you in the next video. Bye-bye.